All right, let's dive in. Have you ever been scrolling through Pinterest and it just feels like it gets you? Like it knows exactly what you're looking for even before you do? Well, today, we're going to design the machine learning system that makes that magic happen. We're going to get on the whiteboard and map out the architecture, the models, and the really clever tricks that deliver personalized content to millions of people every single day.
So here's our game plan. We'll tackle this in 4 parts. We'll start with the blueprint, getting the requirements down. Then we'll get into the engine room to talk data and modeling. After that, we'll look at the factory, which is all about serving and evaluation. And finally, we'll cover the upgrades, the really cool innovations that take this thing to the next level.
Okay, first up, the blueprint. With any big system design, you absolutely have to start here. If you don't get the requirements right, everything you build on top of it will be on a shaky foundation. So let's get this crystal clear.
So, what are the absolute must-haves for a system like this? Let's jot them down. First, scope. We're not talking about a small app. We need to personalize content for millions and millions of users. Then there's the scale. We have to find the perfect pins from a library of billions of them. That's a massive search problem. Diversity is also key. A user might be shopping one minute and looking for recipes the next. We have to serve all those different intents. And finally, the big one, latency. This thing has to be fast, like under 200 milliseconds fast. That's not negotiable.
Given those constraints, how do we frame this as a machine learning task? Well, it's pretty clear. It's a massive ranking problem. We take a bunch of inputs, what we know about the user, what we know about the pins, and the current context, like time of day, and what do we spit out? A perfectly ranked, personalized list of pins that we think that user will love. And to do this at scale, we're going to lean heavily on a technique called embedding-based retrieval. Think of it as creating a super smart map where similar users and pins are placed close together, making it easy to find great matches instantly.
Right, we've got our blueprint. Now it's time to build the engine. This is the core of the system, the data that fuels it and the models that provide the horsepower.
So what kind of data are we feeding this beast? It falls into 3 buckets. We've got user features, your click history, what topics you follow, that kind of thing. Then we have pin features, everything about the pin itself, like its image, text, and category. And finally, we have contextual features, the right now data, like where you are, what time it is, and what device you're on. These are the raw ingredients our model is going to cook with.
Okay, let's talk models. A really common starting point for a problem like this is a 2-tower model. It's fast, it's efficient, but it has one big blind spot. It treats all the features in each tower independently. But think about it. A movie's director and its genre are useful on their own, but knowing them together tells you so much more. That's where feature crossing comes in. It's about letting the model learn those powerful interactions.
So how did Pinterest actually implement this at their scale? Well, they started with an architecture called MaskNet, which gave them a nice little bump in engaged sessions. But they didn't stop there. They built something even more powerful, called the DHEN framework. You can think of it as a team of models. It combines MaskNet with other layers like MLPs and even Transformers. This next-level approach gave them another boost in engagement. And get this, over a 1% lift in saves and clicks, which at Pinterest scale is absolutely massive.
Now, another huge lever they pulled was using pre-trained ID embeddings, basically really smart numerical representations for every single user and pin. The problem? When they tried to fine-tune these, the model started to overfit like crazy, so they had to debug this. Their first attempt was to just freeze the embeddings and apply a ton of dropout. It kind of worked. But the real breakthrough was a super clever trick. They made sure that the embedding table they used was trained on data from a completely different time window than the main model. That solved the overlap issue and gave them a huge win.
Okay, so we've got our sophisticated model designed, but a model on a laptop is useless. We need to get it into production. So now let's head to the factory, where we'll talk about how we actually serve these recommendations and, just as importantly, how we measure if they're any good.
When you're evaluating a system like this, you really live in 2 different worlds. There's the offline world, which is like the lab. Before we deploy anything, we check if the model is producing high-quality rankings. The key metric here is NDCG, which basically just answers the question, are we putting the absolute best stuff at the very top of the list? But the lab isn't reality. The ultimate source of truth is online A/B testing. This is where we see if real users are actually engaging more, clicking, saving, repinning. That's what really matters.
Now, I want to talk about something that is so critical but often gets forgotten, the quality of your serving corpus. It doesn't matter if you have the smartest model in the world. If the pool of pins it has to choose from is stale or low quality, your recommendations are going to be low quality.
It's that simple. Your corpus is the absolute ceiling on your system's performance.
So the Pinterest team did a full corpus renovation. Their old method was too simple. It just looked at total engagement over the last 90 days. But that misses what's trending right now. So they switched to a time-decayed approach, which gives more weight to recent popularity. They also squashed a subtle data bug. And check this out, just by improving their data quality, they saw a significant lift in engaged sessions. No model changes at all. That just shows you data quality is everything.
All right, this brings us to our final section, the upgrades. This is where we get into the really cutting-edge stuff. We're going to look at some of the biggest challenges and recommendations today, and the truly innovative solutions Pinterest came up with to solve them. So here's a fundamental problem. Think about how you use Pinterest. You're not just one thing. 1 minute you're looking for home decor ideas, the next you're planning a vacation. So how can a single model, which creates just one mathematical representation of you, possibly capture all those different sides of your personality at once?
The answer is brilliant. You don't use one representation. You use multiple. It's a technique called multi-embedding retrieval. They use a special type of neural network called a capsule network to generate several different embeddings for each user. One might represent your foodie side, another your DIY project side, and a third your fashion side. Then, at serving time, it pulls a few candidates from each of those buckets and mixes them together. It's an absolute game changer for improving the diversity of the feed.
Okay, second challenge. You know how you can follow specific topics like street photography? It's a great source of content, but often those recommendations are pretty generic and don't feel very personal, so engagement can be low. The question is, how do you make those recommendations feel like they were picked just for you?
This is where conditional retrieval comes in, and it's super smart. The idea is to take that interest the user follows, let's say it's iced coffee, and feed it directly into the user model as an extra piece of information. This forces the model to think, okay, find things this specific person would like, but only within the topic of iced coffee. It basically turns the recommender into a hyper-personalized search engine for your interests, and it works incredibly well.
So if you boil this entire system design down to one core philosophy, it's this quote from the Pinterest engineers: "A single embedding is inadequate to represent all sorts of user intents." Every single innovation we've discussed today is about moving past that simplistic idea. It's about building a system that understands that you're not just one thing. You're a complex, creative person with interests that change and evolve. And building a system that truly respects that complexity, well, that's the blueprint for a world-class recommender system.